Okay, let's see what we have here. You are given a sorted unique integer array called nums. Arrange AB is the set of all integers from A to B inclusive. Return the smallest sorted list of ranges that cover all the numbers in the array exactly. Each element of nums is covered by exactly one of the ranges, and there is no integer x such that x is in one of the ranges but not in nums. Each range A and B in the list should be output as A to B if A is not equal to B, and A if A is equal to B. First of all, we need to make sure that our edge case is captured. So if not nums, then we are going to return an empty list. Okay. Second thing that we need to do, we need to loop over all the items by storing somewhere. So for us to store it somewhere, we need to create another variable. We're going to call it and it's going to be an empty. So we are very sure that you're going to return nums at the end of the day because it's going to carry our results. So let us return it here and come back and continue. Now, looping over all the items in nums, we need to start somewhere. So we are going to create a starting point. We're going to call it I and initialize it to 0. Now we're going to loop over and say while I is less than the length of nums. So we are going to create a starting point. And we're going to say the starting point of this loop is going to be nums at index I. Okay. Now, because we have the starting point, which is going to be the exact element at index I, we also need to create the end element. Now, here we are going to check. So here we are going to start the loop of creating the last element. While I is less than the length of nums minus 1, so that we don't go outside the bound. And now we are going to loop over and check if A is not equal to B or A is equal to B. So we'll come here and say nums index I plus 1. So the element at index I plus 1, if it is equal to nums at index I plus 1. The element at index I plus 1 is supposed to be the sum of the current index plus 1. So if this is going to be the case, then we're going to increment I by 1. Okay, now we are going to have our ending point. Now we'll come here and check if the start point is not equal to the last point, which is going to be our current element at index I, then that means we are going to push append the start plus we are going to have the arrow so that we can have the range plus the end, which is our current nums at index I. Now remember, this is a number and also this is a number, but now we are returning strings. So we need to convert start to string by wrapping it with an str. In Python, we convert a number into string like that. We wrap it str. So this one is going to be starting to the end. Now, in case that doesn't happen, else, it means that the starting point of our loop is the ending point of our loop. So in this case, we are having 7 as the starting point and also 7 as the ending point because it doesn't have any other item that is going to be equal to it plus 1. Now we are going to push append the current, convert it into a string, the current nums at index I. Okay, so from there, we increase I by 1, so that this one is going to change from the current index to the next index. Once this loop is done and all the ranges have been updated to our answer array, that is where we are going to return the answer that we already returned here. Now I want to go through this code again so that I can make sure that everything is running well before I run it. So here we are checking if this one has any elements. So this is correct. We are creating our array that is going to hold the result. We are creating our first index. You're going to loop as long as our first index is going to be less than the length of the num, our starting index. Then we are going to update until we get to our last index. So we're making sure that we are working inside the bound. So I is going to be less than the length of num minus 1. The reason as to why you're going to do minus 1, in this example, we have 1, 2, 3, 4, 5, 6. So these are 6 elements. But in indexing, it's supposed to be up to index 5. So you're subtracting 1 so that you can get the index. Then, if this one is true, we're also going to check if this is also true. The element at the next index should be the sum of the current index plus 1. So if this is going to be true, then you're going to increase I until this law is broken. So if it is broken, we're going to check if start, the one that we created here, is it equal to nums at the current index or not? If it is not equal, then you are going to append start and last index, which is the current index that when you add 1 is not going to be equal to the next item. And you're going to add the arrow here. Now else, we are going to return the start, because at this point, the start is going to be the same as the last index. So that means the current item, if you add 1 on top of it, it's not going to give you the next element. For instance, when you add 1 to 6, it's not going to give you 8, it's going to give you 7. 7 is missing in this example. So we are going to add 1 so that you can move to the next index. We're increasing. This algorithm is fine. I'm going to run it. Then you're going to check the time complexity. Yes, it has passed the way we expected it to pass. Let us look at the time complexity of this question. Time, big O of. So we are going to see, we have a loop here, which is going to be big O of n. Big O of n. Then there is a catch here. This is not a loop per se. This is just checking if this current I is less than the length of nums. It's not looping over anything. It's just checking. So it has a time complexity of big O of 1. So this makes our time complexity to be big O of n, where n is the number of items in the array. Okay, space complexity going to be big O of so here we are creating the array and all the items in the nums are going to be pushed here as we continue. So this one is going to be also big O of n. So that is how we handle that question. Thank you so much for watching, and I hope to see you in the next one. Bye bye.